Hi everyone, this is a video with some naming examples for aromatic compounds. I have three examples, and we're going to basically follow the naming rules for cycloalkanes for our branches, but we have this big distinction for us when we're dealing with aromatic compounds. It does make a difference if the benzene is acting like the longest chain or if the benzene is acting like a branch. If the benzene is attached to a carbon chain of 7 carbons or longer, then the benzene acts like a branch called phenol. We're going to see that with our third example. The first example just has a methyl on it. So clearly then the dominant structure is the benzene ring, this aromatic situation. If we see it, we say benzene. A hexagon with a circle inside it is the symbol for benzene. If you see it, then you say benzene. For branches, we're going to follow these really well-established, traditional, familiar, I hope, sounding rules. But to give the digit, if there's only one branch, don't put a number. If there's multiple branches, start numbering at a branch and count clockwise or counterclockwise to keep the numbers as small as possible. Here's a branch with 1 carbon in it. We're very familiar with that by now. It's methyl. Because we're following the same rules as for cycloalkanes, if there is only one branch, we're not going to use a number to show that branch's location. So this first example is only methylbenzene. Moving on to the second example, this time it has 2 branches, but they both have 2 carbons in the branch. I would encourage you to try and work it faster than I am. This is a branch with 2 carbons in it. This is a branch with 2 carbons. Benzene is again the dominant structure. So if we see it, and benzene is the dominant structure, the name ends with benzene. How about the name? This is a branch with 2 carbons in it. This is also a branch with 2 carbons in it. 2 branches, but they're the same kind of branch with 2 carbons. A branch with 2 carbons in it is called ethyl. Branches are officially called alkyl groups, so the names always end in YL. Meth is the prefix for 1 carbon, and eth is the prefix for 2 carbons. But we have 2 different ethyls. This is diethylbenzene. Now, we're in the situation where we have multiple branches, so we want to start numbering at a branch. Which branch should I start numbering at? It doesn't matter. Pick a branch and call that carbon number 1. This is carbon number 1. Now I need to go clockwise or counterclockwise to give the other branch the smallest number possible. If we go counterclockwise, we have carbon number 1, 2, 3, 4, 5. We would have a 1 and a 5. But if we go in the clockwise direction, we get 1, 2, 3. This branch is on the 3rd carbon. Now clearly, 1 and 3 is smaller than 1 and 5. That's what we have to go with. This is 1, 3, 1,3 diethylbenzene. The dominant structure is benzene, a 6-carbon ring with a circle in the middle. There's a branch, ethyl, with 2 carbons in it, eth. But there's 2 of them, diethyl. And where are those branches? Attached to carbon number 1 and carbon number 3 of the chain. We also have the possibility where benzene is not the dominant structure, where benzene is acting like a branch. If it's attached to a carbon chain of 7 or more carbons, then the benzene acts like a branch. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in the longest chain. Let me highlight those by putting a dot in the location of each carbon. Don't forget to count the ends of the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a carbon chain with 9 carbons of all single bonds. 9 single bonded carbons is non-ane. Single bonded carbons means we end with ane, and there's 9 of them, non. Now we have a branch. This right here is a branch with 1 carbon in it. It's methyl. Here we see the benzene ring. It's acting like a branch, and it is called phenyl. We need to name these branches alphabetically. A, B, and we go through the alphabet. And M for methyl comes before P for phenyl. So as we write this out, we're going to have methyl on the left-hand part of the name and the phenyl right before the non-ane. We need to now use digits to show the location of the methyl and to show the location of the phenyl. It should stand out that both of these branches are closer to the right-hand side of this molecule, so we're going to count this direction. We have 1, 2, 3. On the 3rd carbon is where the phenyl is attached. 1, 2, 3. And the 4th carbon is where the methyl is. We end up with 4-methyl, 3-phenyl non-ane. We have single bonded carbons, 9 of them. We have a branch called phenyl, which is the benzene ring, on the 3rd carbon of the parent chain. We also have a branch with 1 carbon in it, methyl, attached to the 4th carbon of the parent chain. 4-methyl, 3-phenyl non-ane. Finally, it's important to emphasize one more time that whether benzene is acting like the longest chain, and we're using the word benzene in our name, or if benzene is acting like a branch and we're calling it phenyl, as long as there is a benzene ring, these 3 molecules would be classified as aromatic. I hope that helps.